Well, hello guys, here Mr. G with another video. This time is going to be a question for the grade 12 and we're going to be answering question 10 from the Eastern Cape September done in 2023. But before we carry on, don't forget to subscribe for the channel so you can get all notifications and videos I post on regular basis. This question is going to be about photoelectric effect. It's the last question of the paper. And the question said an investigation is done to determine the effect of power of a light bulb on the current which is generated in photoelectric cells. The apparatus used in this investigation is shown in the simplified diagram below. Ultraviolet light of wavelengths 490 nanometers emitted by two bulbs A and B is shown into a cathode of the photoelectric cell, and the maximum speed of the ejected photoelectrons is measured. And here you have the apparatus of what happened. Light of certain wavelengths is incident on this metal, and electrons are going to be released, and as a result of that, an electric current will flow in the circuit. The result of the investigation are shown in the table below, and then you have a table here in which you have two light bulbs A and B. Power of the light bulb, you have different power of the light bulb, maximum speed of photoelectrons. I want you to know that this power of the light bulb will have an influence on the intensity of light. Okay, when you change this power, you are going to change the intensity of this light bulb, or the light, not the light bulb, but the intensity of the light will change. Question 10.1. Describe the term photoelectric effect. And we already started with some small space, so let's go to a new page here. And what we have to say, what is photoelectric effect? It's the process whereby electrons are ejected from a metal surface when light of suitable frequency is incident on the surface. Guys, you are 98% of the probability that this definition is going to be asked in the exam. So please make sure you learn it. Let's go to question 10.2. Verify and explain why the power of light bulbs does not affect the maximum speed of the ejected electron. Remember what I say, the increasing the power here, what does affect is actually the intensity. All right, as you affect the light, change the power of light, the intensity of light will be either greater or bigger. So when you change the power here, the intensity change, and the intensity change the number of photoelectrons, not the speed of the photoelectron. So that is what you need to know. As you change the power, you are changing the intensity, and the intensity of the light will only affect the number of photoelectrons because it comes with more photons. Okay, so the first thing we have to say here is that increasing the power will increase the intensity of light. All right, increasing the power will increase the intensity of light. Then the intensity of light will increase the number of photoelectrons. The higher the intensity or the greater the intensity, the more photoelectrons will be ejected. And finally, we are going to say that the kinetic energy of the photoelectron is independent of the intensity of light. Guys, the intensity of light, which in other words means how strong the light is or how weak the light is, will only affect the number of photoelectrons and not the kinetic energy of the photoelectrons. And guys, this one is 2 marks. 2 marks. One for saying that one, and one for saying that the kinetic energy does not get affected by the intensity of light. Well, now we go into question 10.3. Which of the two light bulbs, A or B, will produce the highest reading on the ammeter? Explain your answer. And in this case, the answer is light B. So the answer is light B, because it has a high intensity, and therefore more photoelectrons will be ejected, and therefore more current. Ammeter reading will be higher. Also, that is what we have to say here. Okay, so what will be the complete answer? The answer is B. It has a higher intensity. Higher intensity is important here, and therefore more photoelectrons will be ejected, and therefore more current. So that is 1 mark for saying B and 1 mark for saying the rest of the explanation here. Calculate the energy of the ultraviolet photons. Now they want you to calculate the energy of the photon of the ultraviolet. Guys, they are giving you here the wavelength, say ultraviolet light of wavelength 490 nanometers. So they are giving you the wavelength. Energy of photons, we are right here. Important, there is an H, which is going to be one of the constants we are going to be using right now in the next minute. There is a constant H, and the formulas, all of them are going to be let's quickly look for them. No, not there. Formulas of light. Here they are. Here are the formulas, and then add some formulas here and other ones that are not here. Now, this one here can be used by combining it with the one of frequency, which is that one there. Okay, so if that one you combine it, you will get that E is equal to H. If you rearrange this one, you get that frequency is equal to V over lambda. Speed of light is C divided by lambda. Okay, so if you substitute that one, you get C divided by lambda. This is the formula we're going to use, which is in actual fact here, guys. It is right here next to it. I didn't see it there. Okay, so that one is the formula we're going to use to calculate the energy of a photon. This one is for photons. Okay, so we are coming here. This one is question 10.4.2, and then energy is equal to H multiplied by the speed of light and divided by a lambda. Everything is given to us. Remember, lambda is given in nanometers, and therefore we have to convert. All the information is given. C and H are constants that you're going to get in that table. So when you substitute, you get 6,63 times 10 to the minus 34 multiplied by the speed of light, which is 3 times 10 to the 8 divided by 490. Let's fix that one. 490 nanometers. Therefore, you say times 10 to the minus 9. And when you calculate that one, you will get that the energy of the photon is 4,0. This is let's fix it at 4,06 times 10 to the minus 19 joules, and this is the answer here. Okay, that is the final answer. Where are the marks here? It's quite simple, and it's only 3 marks. One for the formula, one for the substitution, one for the final answer. Quite simple. And then the final question say calculate the work function of the metal cathode. And for the work function, guys, we're going to calculate to use this formula here. Let me change here the color so you can see this formula here. There we go. We have the energy of the photon we just calculated. We have the kinetic energy is given to us in the table, and then all the information is given here. So let's go and calculate that one. 10.4.2. This one is in actual fact 1 here. Okay, so that is the question. What are we going to use? We're going to use this formula. E is equal to work function plus kinetic energy, and this one is a maximum kinetic energy. Okay, so that is the one. The energy here, it was calculated. It was 4,06 times 10 to the minus 19 work function we are looking for, and kinetic energy is given to us in the table. Well, no, the kinetic energy is not given, the maximum speed is given. Let's go back to the table. Here we are, they're giving us the maximum speed of the photoelectrons, okay? So we don't have to worry. All we have to do is to substitute the formula for kinetic energy, half mass multiplied by the speed squared, the maximum speed squared. Guys, mass of the electron. So when we substitute everything here, now we get that is 4,06 times 10 to the minus 19 is equal to work function plus half mass of the electron, which we know it is in the table of constants, 9,11 times 10 to the minus 31 multiplied by the speed, which is given in the table I just showed you, 7,5 times 10 to the 5, and this is to the power 2 because it's the maximum speed in this case. So the work function, when you do that simple calculation, you should get that is 1,5 times 10 to the minus 19 joules. That is the work function. That is the final answer for this question, and this is the final question of the question paper. The marking, well, there's one for the formula, one for the substitution of the energy of photon that we did calculate previously there. So whatever answer you get here will be substitute in that side, and this one here get 1 mark for all the substitution on the right hand side and 1 for the final answer, and this is the end. Guys, thank you for watching. I hope it helped. A thumb up, subscribe for the channel. I'll see you next time. Mr. G here.